Hello, this is about a video to explain why I hate Rust programming language. This video is all about the negativity of Rust. If you think, I don't want to talk about anything positive because you can all watch all these nonsense, echo chamber, Rust, safe, whatever nonsense video. And you can just go to the Reddit or other videos. They will tell you how good Rust is. They're going to talk how good Rust is. And Rust is always good and they have no downside. So now first thing I want to talk about is the binary bloat issues. But before I talking about that, I'm going to explain why binary size is extremely important, right? Now the first problem is that a lot of special environments, they have the size restrictions, right? They have the binary size restrictions like the operating system kernel, like the bootloaders, that embedded system, or even WebAssembly. You have these size restrictions. And even GitHub has these upload size limitations. You cannot upload anything which is larger than 100 megabytes. That is very problematic. And this is very problematic for, I try to upload clan, and clan is too large compared to GCC, and I cannot upload clan to the GitHub. That's very problematic. And second, binary size directly affects the performance of a program. Because if you have a larger binary size, it adds burden to the CPU cache locality and page locality, right? You have larger binary size, you're gonna get more page fault. You're gonna get more instruction cache miss. That just directly affects the performance. And third, I think a lot of people don't know it is that a larger binary size will severely harm the security of your program because it provides more return-oriented programming gadgets. The attacker can just use those bloating parts to attack your program, right? You provide these functionalities that they can reuse that part to attack your program, right? That's how this return-oriented programming attack is formed. Despite all these God, whatever, it just doesn't work because ROP is a very serious issue, right? It just directly leads to control flow integrity problems. So let's just see how bloat a Rust program is. So here I'm just writing a fun main, right? Just doing nothing, just a function main, right? Just add a function main, and what you do is just nothing, a simple program. And here we have a C++ int main, right? Just compare the two of them, and we can see if you try to compile the code. I'm doing optimization. Look here, it's all here, and we can see the binary size is 10 megabytes before streaming. You say streaming, not streaming bloat because it provides a lot of lots of debugging information. It doesn't make sense. Then just streaming. Then streaming the binary, and the binary is 283 kilobytes. That is huge, right? This is huge. Now you might say it's because Rust has these static linking models. I would explain that is not the case. So we have the C++ program, and we do the same thing. We time it with static lib GCC or static C++ because I just want to compare two of them to see whether the static linking is a problem. We're just using the function and int main as example. And C++ program is only 14 kilobytes on Linux. It's 15 kilobytes on Windows, and so it is 14 to 15, for example, or even some platforms only 2 or 3 kilobytes, or whatever. But no matter what platform you're using, you'll see that just writing a main function will only take 14 kilobytes compared to 283 kilobytes of Rust, which means just in the main, the Rust program blows 20 times than the C++. So Rust program is very bloated, And if we try to see the compilation speed, that's just doing that. It takes 0.1 second, 0.16 second. Well, it's just ridiculous, right? It's completely ridiculous, and probably we need to add them together or something. But it's just 0.16 second of compile function main. So even the compilation speed is extremely terrible, right? The program doesn't do anything. It just function main, but it takes 0.16 second. That's ridiculous. So the binary size is extremely bloat, and the compilation time doesn't seem to be very good either. And if we try to use the LDD to see what the shared libraries it links to, and you can see not only it's not fully static linking, right? It still need to link with libgcc because of the unwind logic with it. You might say I can just using cpanic equals about whatever. I've tried that. It's still linked to libgcc because the Rust standard library still requires functionalities in libgcc as for unwinding stuff. And if we see the C++ programs, we can see it actually, the difference here is that C++ program or C or C++ program will link to libm. I don't know why they link to libm, but let's just ignore the part. But they don't link to libpthread. They don't link to libgcc, right? They don't link to libdr either, right? So these three parts just doesn't make any sense. I'm not using any thread. Why does it link to libpthread? Why does it link to libdr, right? So yeah, it's just very problematic. Okay, so you might say, what about hello world? Okay, just what about printing hello world? So I'm just doing the standardized things. I'm just I'm not disable exceptions. I'm just disable exception is much smaller, but just print hello world. So with printing hello world, it's doing the same thing as Rust is doing, but it's only 14 kilobytes. Notice I'm not using shared library linked to some libfastio or whatever. I don't use shared library at all. And you see the binary size of Rust is still 20 times larger. This is doing nothing, okay? This is doing nothing. But in fastio case, we have the 14. Oh, this is not 14 kilobytes. I'm sorry, it's 14 bytes. It's bytes, not kilobytes. Okay, it's 14 kilobytes. So the Rust program is 20 times larger than C++ program, even with static link, whatever, basically. So it's basically very, very bad. The binary bloat is extremely bad. So you might say, intermain doesn't make any sense, right? Because I can deal with it. Okay, I will tell you a story that zero cost abstraction is just a joke and meme. Okay, it fails in C++, it fails in other languages. There are simply no zero cost abstractions. I think I can show an example of a square here. Okay, so here's a Rust program. Okay, see what it actually does. So we'll just try to access slide 0, 1, 2, 3, 4, 5, and you can see the compiler is extremely dumb. It checks the bounds for every of the subscriptor access, right? We access every index. It checks whether you have whether it's out of file, whether it is out of file. And you can see if we just continue like that, it will add another more branch. Okay, the compilation speed is also very terrible. I notice I'm using O3. Okay, I'm using O3. So let's see what the program actually does. So you can see here it actually generates string for every bound checking. So the Rust folk it's not even efficient for checking these bounds. They are not just a minimum check. What it actually does is they check bounds for that give you an error message of which line you have the problem. We can see that the string line is different. Okay, see this is probably 3. I think is tell you you have an error in the string. In a 3, you have an error 4, 5, 6, and whatever. And if we write the same code with C++, okay, so Rust program generates 5 times more. Probably this kind of part, I just ignore that part because it's only some constant. If you just take on the instruction part, it's nearly 10 times, right? It's just 10 times. I think it's 10 times more instructions than C++ generates. And you can see the boundary checking actually harms the other optimizations. When you have boundary checking, the compiler cannot, it has to push another register, cannot do vectorization. See here we do O3 too, and you can see the compiler cannot do vectorization anymore with Rust because you have the extra boundary checking right there. And you have these binary bloat here, right? You have the binary bloat here. It's going to be extremely slow. It's not as just small slowdown. It's very significant slowdown. Even the happy part, right? It's the code will execute part. Still generates nearly 3 times more instructions than C. Not much more instructions than C++. Right? 3 times instructions. Now you will see a significant overhead with it. And you can see here, probably it has even fewer memory access because it's vectorized. We have vectorized the stuff. I think the further herd optimization with MRKC, probably going to use MYY register, right? It's going to further harm the optimization compared to Rust boundary checking is doing. So Rust program is extremely bloat, and the panic part is extremely bad. You must say, it's panic. Can I just use C panic to about what's going to happen with that? Nothing changes. Okay, nothing changes here. We don't see any changes. It doesn't improve the quality of the program, and you must say whether because we enable exception. You can see we did enable optimizations. We don't. It just the binary bloat even worse, right? The code is extremely slow. So the argument that Rust is as fast as C++, this doesn't make any sense. You have to use Unsafe to get rid of the problems. You have to use Unsafe get index on check whatever just to get rid of the problems with it. It's not like Rust, for example, or bounce checking doesn't make your code slow down. It does make your code slow down because there are no zero cost abstractions. I think there are the problems with Rust. In my opinion, the personal opinion is that I think you wrapping the C APIs is much harder and error prone compared to C++. You might say we have code generator like code by binding generator, bygen, right? With Rust, you can translate it C headers to Rust, but in fact there are no zero cost abstractions, right? You use these code generators, they are going to bloat your compilation speed. Okay, and then run. We already know Rust compilation speed is a horrible mess, right? It's just so slow, right? C++ is already very slow, and it has the major problem is that it has to reparse the header files. But Rust makes it slow down. It will just make it even more slower. It is significantly slower, and which is ridiculous. The versioning issues, right? When you're using this code generator part, how do you ensure you don't have versioning issues with it? Probably you can just parse the entire file with Rust, but it still doesn't make any sense, right? It just making things extremely hard and problematic, and you cannot see what the import is, and in general, it makes you lack of control, right? You have no control of all these code generators doing. These hide of things, these things that tries to hide things behind are very problematic. You want to do very things. You want to know what is going on. These stuff are very problematic, to be honest. Okay, so so there's a philosophical debate with the unsafe keyword in Rust. So a lot of Rust zealots will say unsafe should never ever be used, right? Because our language is designed for safety. If you're just using unsafe everywhere, then what's the point of using the language anymore? Okay, so they already defeat their own language purpose. What's the point of using Rust? There's no point of using Rust, in my opinion. So all you are saying, okay, unsafe should only be used in exceptional circumstances. So when to use unsafe, right? You know, it's very like the old lies in C++. The C++, they claim that exceptions should only be using exceptional circumstances, right? That leads to pain, right? Particularly why C++ is very bad for writing operating system kernel. It's because of these bad assumptions, right? C++ already suffers from the exceptions should be only using exceptional circumstances. I think Rust suffers from the unsafe should only be using exceptional circumstances too. Nobody knows when to use unsafe, right? When to use unsafe. You cannot give me a standard saying when to use unsafe is appropriate, when it's not. You might say I'm using only FFI APIs should only use unsafe. But people don't do that. People say, hey, I'm using unsafe, I can get much better performance. I can defeat borrow checkers, right? I can defeat all these nonsense in Rust. And how do you give me a standard saying when to use unsafe? Okay, the problem is vagueness. These questions are vague questions. There's no answer for these questions, right? Right? There's no questions. There's just no way to have these questions. And okay, what finally you're gonna do? You're gonna do it. What you're gonna do is using 100% of unsafe to avoid dramas, right? You cannot use safe in any part of your code because you'll never be able to know whether this safe code will either lead to binary bloat or lead to other CPU performance issues or lead to other issues. Particularly my code is basically talking with operating system APIs or just do point manipulations. In that kind of code, I have to basically using 100% of unsafe, right? And using 100% unsafe just can avoid these trolls in Rust saying you should never use unsafe. You can just use 100% unsafe to make them shut up, right? Because they are going to come here and pick a grammar place to destroy your project, like as the web is doing, right? So the Rust Zealots will say, let's just rewrite everything in Rust. So these questions, I think it's impossible, right? Like libc, like POSIX. Can you rewrite POSIX or write libc? No, you cannot, because POSIX is the operating system standard. You know, I think this a lot of people don't understand. POSIX is the operating system standard, just like WD40, just ISO-C is a C standard. ISO-C++ is C++ language standard. POSIX is the operating system standard. It provides the basic interface for talking to operating system, right? To ensure your program is portable. You might say Windows does not follow POSIX. Well, that's not technically correct. Windows does follow partial POSIX. Okay, if you read or if you watch my talk about it, I will tell you that yes, Windows follow partial POSIX. So POSIX is the operating system standard. And you must provide a libc to bootstrap a compiler torsion, right? The compiler, including LVM or GCC, you must provide a libc to it. And GCC needs the libc to compile libgcc and libsu C++. Then we get a for torsion with it, a for cross torsion with it. And we can then build a Canadian cross torsion. Then we have a new compiler, new hosted compiler. Well, if you don't provide POSIX, what are you going to do with it? It's impossible, right? You might say, I'm just designing APIs for Rust, but we also have many other languages like Python, like this Java, whatever. These languages don't understand your Rust abstractions. They're just like they don't understand C++ abstraction. I think they probably understand more C++ abstractions than Rust abstractions. Like Java can understand C++ exceptions, for example. Just C++ exceptions, the ELF standard said how exceptions is thrown and how the API is performed. And C++ API is relatively more stable than Rust, right? But even so, people don't use C++ to write anything because you still worry about when the API will break. If we're using Rust, how are you going to solve these problems? Finally, you can just going to provide them C APIs and defeat the purpose, right? Which means you're basically rewriting something which is nonsense, then you rewrite it. It just makes no sense. You cannot replace POSIX. You cannot replace this old bad standard. How do you get with it? How can you do it? So let's just use a case study. Let's just assume we use Rust to rewrite OpenSSL. Okay. The cryptography libraries usually require the intrinsic usage. They have to use add carry instructions, for example, or rotate with carry instructions. Like OpenSSL, we can see OpenSSL code. I think I can show OpenSSL. I think I did put here. Okay, just to mess. I'm sorry, I messed here. The mess is up. OpenSSL. So sharp. Okay, let's just use sharp for example. I'll just use sharp. Sharp is very simple stuff, but we can see the OpenSSL actually provides a lot of assembly implementation with it, right? I fail to see how using Rust would fix those problems, right? They are reading assembly. How are you going to fix these problems, right? You probably say, oh, I can rewrite it with intrinsics. Okay, you probably can rewrite it with intrinsics, but it doesn't make any sense because here's the already code generated. If you're using intrinsics, you still need unsafe. It's not like Rust said we can just save everything, right? I think OpenSSL is exactly an example. You cannot use the safe language to write it because what they actually did is just writing assembly, right? They just write assembly. How are you going to deal with it, right? So basically, they have to use assembly. So the Rust does not work. Okay. You might say, I want fast. I don't care about performance. I want slower code. This Rust folks logic, but there are other very good reasons why they are writing this assembly. It's to calling these CPU instructions like SHA-215/6 to provide side channels, right? That can reduce the memory access if you're using these special instructions. These special instructions provide protections to prevent these side channels issues. So it's just basically impossible. You say we rewrite Rust, we can solve those problems. There are problems can be solved with Rust to rewrite OpenSSL, like the OpenSSL BIOS problem, right? The OpenSSL is also an IO library, but I mean it's still doubtful. I'm doubtful about that because for Rust themselves, the IO performance, the IO stuff of Rust is horrible. It's even I would argue even horrible than C++ IO stream. How do you trust Rust to do better job than OpenSSL is doing here? They already have fuzzing. They already have all this stuff. Probably they can improve a lot of things by rewriting C++. But and then what's the benefit of using Rust? Right? There's no benefit at all for me compared to other solutions. You rewrite everything in Rust. How do you know how new Rust code won't introduce more CVEs? You don't know, right? And there are also other problems with it. People are using Unsafe to fight against the borrow checker, right? Because they cannot write linked lists, they cannot write anything because the borrow checker is fighting them. What they can do is I'm using Unsafe to fight against it, right? So there's this typical experience with me. I think there's a Rust program. He was a Rust programmer. Okay, he tried to use Rust, but he finds that what he actually do is using a tons of Unsafe to fight against borrow checker, using Unwrap a lot of functions, and saying what's the point of using it? I'm go back to C++. So I feel it just makes no sense, right? The language is poorly designed basically. And I don't think there are any other languages you try to just fight against the safety mechanism. It just makes no sense, right? Just may fighting against the borrow checker, right? Rust said we don't have garbage collection. Okay, that's probably a good side, but the downside is that you don't have garbage collection, then you have to introduce these borrow checker stuff, then people are gonna fight with it. And how do you gonna deal with it? And people just using Unsafe to fight it. So it's very problematic. And about the Unwrap abuse, I think the API is even the Rust standard library API is designed very poorly, like the FFI API. It's a very poorly API. Okay, here what I did is just using an fopen and fclose. I want to see what's happening here. Okay, so I just wrap an fopen and fclose, and it just makes me wonder. Just make me curious. Why do you need Unwrap on C string, right? How could C string fail? I fail to understand. Even in C and C++, you can just fopen rust.txt wb, right? They already provide no terminator with it. But I think probably with Rust is that the default string literals don't have the no terminator, and you have to use the C string to get around it. So it's slower, right? This is already slower because you have to allocate string, you have to deal with allocation, and this unwrap. Okay, notice that unwrap here. What's the point here of unwrap, using unwrap if it just make any sense? It doesn't make any sense, right? How could the API fails? How could the new API fails? And second, why do I need unwrap it? Okay, it's just ridiculous. I mean, this API is ridiculous. And even so, the API is incorrect because you can see we cannot see void exploit it. We should write an opaque fire, right? Opaque fire instead of using void. Or you don't know whether you have the aliasing issues with other problem with it because it's not the same type. So whatever. Maybe the API is imported incorrectly, but I just want to try it. But in general, it's a serious problem in Rust. It's basically unwrap everything because you have to deal with it. You have no other solutions. You cannot say I'm just using a question mark to propagate error code. You cannot do that either because you have a different error code. How do you get to deal with it? So I think the Rust error handling mechanism it's still bad. It's bad. It might be better than C++ exceptions because C++ exception is horrible. But I fail to see how this expected unwinded stuff is better. Just still crap. It's just still crap. Okay, I think the herb session is actually very good because you don't have these different types of error code, how to propagate them problem. They always propagate through registers. You don't have to deal with the dynamic typings. You don't have to deal with heap allocations. Here you still need to deal with these things. Finally, what you're going to do is unwrap all your APIs to avoid dramas. And it's very problematic when you're calling unwrap. You're calling unwrap, you panic. You have a panic, and Rust panic is very, very badly. You have these CVEs with panic. I'm going to talk about that in a later video, but basically it's very, very terrible. So in Rust, you have to abuse a bunch of unwrap. Unwrap, you have no idea what's going on here. It's just promoting. I think it's very like the Java check exceptions. What people can finally do, they just throw every exception. They don't care how it just ignore all the errors. Basically, that's what they are doing. They don't care about how the error is how you're going to deal with the errors. As long as my code works, I don't care about everything. I just unwrap everything. So which is very important. Okay, the compilation speed. I guess this is something everyone would agree with. I've just read some articles saying that the languages are accidentally misdesigned in a way they cannot be recompiled. You have to recompile entire code just to deal with that. And it also emits a bunch of IRs for the LVM optimizer. The LVM I cannot deal with it either. Like the example I'm showing here, right? It's tough for LVM to deal with those problems. Like the front end emits a bunch of IR, and the language is misdesigned. And you might see how slow it is, right? Beside the implementing example, I think the V language, they actually provide a very good benchmark. They show the benchmark, okay? So You can see the benchmark. So the ROS first is stopped after 30 minutes. Just no optimization. We have no optimization. It just writes ROS C. Okay. We don't optimize code, and the ROS program it compiles extremely slow. Because the V language said, "Oh, this compiles so slow, and I'm just testing small lines of code." Just 2K lines of code, you compile 3.4 seconds. Right? 2K lines of code. 20 kilobytes of code, 3 minutes for 50 seconds. You know, I actually tried that benchmark. I tried 10K benchmark. You know what happening? Even with 64 gigabytes of memory, okay, the ROS compiler is all my memory and get killed by the operating system because the memory consumption of ROS compiler is too large. Okay, it's too large. It's basically impossible to compile a large project here. Even a very serious project, it's impossible to compile with it. It's to a point you cannot compile code. And you can see, with this impossible to compile. And this is the basic conclusion is that ROS is the slowest language for compilation speed compared to all other languages. There's no other languages it's just as bad as ROS. ROS is the worst programming language for compilation speed. Okay. And you know, even the thing is that compared to C++, ROS has its own. They don't have header files to parse, right? C++ does not have modules, and in fact, C++ tried to fix it with some modules. I don't know whether it worked out. But ROS is already moduled, right? They're already using module system. But the language is designed in a way just so slow that even with modules, it still compiles extremely slow. That tells you something that the language is poorly designed in many forms. And probably that's the case. I think ROS in general, they just don't care about technology. What they care about is politics. Like we can talk about it later. So platform support is also somewhat problems like DOS, right? I'm writing DOS programs. Okay, I'm actually writing DOS, but I'm using GCC torch. It doesn't support GCC, right? It doesn't support GCC front back and you have these platforms, and DOS is just an example. What if you're using these platforms which requires GCC? You're gonna deeply screwed, right? Well, I think what they are trying to do is writing a ROS front end, but we haven't seen what's going on here. We're going to see what's going on, but I think it will end up very badly. What about Redux OS? Okay. I'm sorry, I need to just time. Okay. So this is an operating system you're writing in Rust. Let's see what the code is doing. Let's see, just use this example. Look at the code did, right? It just basically unsafe all the functions, right? Unsafe. What does Rust fork told us, right? What do these Rust told us? You don't use unsafe, right? You don't need unsafe. But this project tells you that just unsafe everywhere. Just unsafe entire code. This code is probably better. We can just try other code. This is probably another just that code. A bunch of unsafe, right? Just not just single one. Just not like people said. Oh, I'm just using unsafe in 1 or 2 places. This is ridiculous, right? Unsafe. This is ridiculous. Okay. Why do you just not marking unsafe in entire block? Why are you just using unsafe for each block here? Right. It's just poor code. It's very bad code. They told us we don't need unsafe in our code, in Rust code. This is real world Rust code. Okay. This is real world Rust code. So the Redux OS, I mean, they really have CVEs with it. You know, the language is actually plagued with memory safety CVEs, right? So, the Rust people told us that our language is perfect. We don't have memory safety CVEs. And here's the CVE you have. Okay, double free. Okay, these are all memory safety issues. Okay, these are all memory safety issues, right? Rust people tell us Rust kills all these memory safety issues. What we left is only other problems like overflow, like other stuff. But here you have double free. You have a double free. Okay, double free and double free with panic and job, right? Panic and job in Perl. You have this double free with it. Right? You have double free, you have auto bounce, right? And these are all in CRAD. Okay, we don't know how many real world CVEs actually exist besides CRAD, right? These just only partial of CVEs in Rust. And you can see the CVE numbers is actually looks like growing exponentially with years. I think you can see I think now we have more CVEs in 2021 than entire 2020. Even in 2020, we can see it's a bunch of issues with the double use of free or double free. And you can see this. I find this is something very interesting with these CVEs. Okay, it's that they have double drops with a panic and drop. I don't actually understand what's going on here, but I think what's going on here is that the Rust will continue panic in drop method if drop is bugged. So if continue causing trigger panic, that's very problematic, right? Your program is already bugged, and you continue execute programs in job. Right? Your program should just crash if you have a problem with job. Why do you continue panic? Your program is already in the crop state, right? It shouldn't continue. It should just crash and go and down, right? Because you never be able to know whether the panic, the double free will trigger after these crashing, after you causing these problems. The panic safety issues. Okay, they told us that using Rust, you don't have these exceptions, you don't have exceptional safety issues, but you have these panic safety issues with double free with it. So the point of Rust is safety, right? It's a memory safety. Maybe it's for the Rust. I think for Rust officials, that's the point. Okay, and it's very bad if you're just as a normal Rust user. You're gonna fight with these problems, right? You're gonna fight with this double. This is the fight against the community. The community is very toxic, and they told us you don't have these memory safety issues, and here you have. Okay, and I think here's actually a research paper, an ACM paper, talking about the memory. Let us understanding the memory safety issues in real-world Rust programs. And remember the Redux OS we just mentioned here? I think they actually talk about Redux OS. Redux. Okay. And invalid free in Rust. Okay. Here's the Rust code. Okay. Unsafe. Okay, unsafe. They have the invalid free. And this is OpenSSL PIO. I think this is wrapping the OpenSSL PIO, because wrapping APIs in Rust is much harder than wrapping in C++. And they have these problems. I think these kind of issues are very more likely to happen in Rust compared with C++, right? And these people actually told us even safe to save call chain can have memory safety issues because the compiler can have bugs. So it told us. I think the paper is still biased because the Rust people were just focusing on unsafe part. Basically, they just treating unsafe part as some kind of stuff. But in fact, all kind of categories you have problems. It's just we care about safe to unsafe part too much, and we don't care about other problems. And you can see the largest part is not actually from the unsafe itself, it's from the safe to unsafe part, which is basically the majority case of your Rust program, right? You find you're gonna call unsafe in some APIs, but they hide behind it. They're hiding behind these safe APIs, and you have no idea what the API is going on. That's why I'm saying I think even 100% unsafe will be better than this stuff, because it told you that the API might doing something wrong. So the paper just told us it doesn't work. This solution just doesn't work, and you have the memory safety issues with it. Just plagued with CVEs. The language is plagued with CVEs, but people say it's safe, it's 100% safe, while nobody is talking about these memory safety issues with it. So I think this is very problematic. In fact, okay, I should say in fact, okay, despite. So, of course, the final we're going to talk is community. The Rust community is a very bad community. Okay, now if people say, when people behave, the language doesn't control what people behave. I would argue the opposite. The language controls how people think, right? How you do something actually affects you. For example, if you do something, everything in our life will affect us in some form. Even using a language, right? Using a language deeply affects how we think about a thing, right? When using another tool, you naturally fit into the mind of that environment. That's how humans, as an animal, adapt our environments, right? Adopt whatever. Just to claiming that the toxic community. I think Rust has its worst community of all the programming language I've ever seen. The community is very toxic because the language is designed in a way that makes people becomes very toxic, right? I think it's just very like the World of Warcraft situation. Like people would say, we don't socialize because we don't want to socialize. But yeah, there are other people, group of people would argue, the environment of the game would affect how you think, right? How would people socialize with each other? And we use the socializing will magically come back if we bring that environment back. Is that? I think that statement is correct. I think more people would agree with that statement. Instead of saying the language does not affect how people thinking. Okay, so even the language designers have a very problematic idea. Okay, their mind is. I fail to understand. I think they are very problematic. Rust people believe that tech this is Rust language's own Reddit. This is their own world. Okay, Rust believes tech is and always will be political, right? That tells you that Rust doesn't care about how to improve technology. What they care about is political struggle. What the chairman Mao said, what is politics? Right? He said, she said is that politics is to, it basically is to destroy your enemy, right? It's just making the enemy, you destroy your enemy, that's politics. So basically, I think this is what Rust is doing right now. It's just trying to destroy any other languages, not just for C++, for C and C++, say, oh, they are memory unsafe. We know they are memory unsafe, but they're also trying to destroy other communities, like Go community, right? They think Go you have a garbage collection, Go is a garbage language. They think all these other languages like Python, right? Python is too slow, it's a script language. They should all rewrite these Python programs in Rust, okay? Because they are too slow. You must think, oh, nobody claims that. But we actually see a video claiming that, okay? I will tell you, there's a video talking about that. So, Before talking about that, I want to talk about the drama here. These are real world dramas because this just told you that the toxicity of Rust itself not only tries to destroy other people, it also try to destroy itself, right? I don't know how to pronounce this. It's probably Actix Web, or no ever. It's basically all about unsafe Rust, right? The author of this guy is using unsafe. He wants to chasing the performance of his library, his framework. Oh, it is framework. Technically, there's nothing wrong with it, but people find that they do have some usage, whatever. And just these people, these safe zealots in Rust, they tries to destroy themselves. You should respect any open source project, right? The authors of any open source projects, they put their time, put their effort on something which is right, should benefit the community. But what you're trying to do is you try to destroy it, right? What you are going to do is try, because they are using unsafe to chasing performance. This, right? The reason behind it is like I said, you don't know, right? Like what I said, it's too vague, right? Nobody knows how much unsafe should be used. They are vague questions, right? In C++, people are using because you have this exceptional or should only be using exception segment settings. Finally, all people ban the exceptions, right? Over 50% of C++ projects, according to Hofstadter's survey, ISO CPP survey, bans exceptions. Here is some situation in Rust that you have no standard to say when to use unsafe, when to not. Then the people would do it using unsafe. You cannot say they're using these unsafe usage are incorrect. I think they actually do use it correctly, right? They actually use it correctly. The actually web, they do know what they're doing. But the Rust community say, oh, you are bad or whatever. And then you can, if you just try to search Reddit and they're saying that it's completely disgusting. This is disgusting. Okay, why do you write unsafe? Whatever, just disgusting for me. The community is very bad. This community is toxic. It's just very bad. Right? I think this guy is actually writing good, but I cannot upload him. They consider unsafe as evil, but the whole thing cannot live without unsafe, right? This is typical Rust community. The Rust community just promotes kind of toxic behavior. The language is very toxic and it's very problematic. And okay, you can watch this video if you think why Rust thinks text is always and will be politics. This is very, very bad, very bad. So this is another video that talks about Actix Web, and this guy was a Rust user, and he makes some very good points here, I think. He's saying these benchmarks are cheating, right? I'm not saying whether these benchmarks are cheating, and the simple fact is that some of them even post their blogs and GUI applications on Crates.io. It's a hot mess, right? He's actually arguing the very good point. I think people should go here and watch this video. I think this here is just downfall of web Actix Web. You can just find out. I think it's very hard to find, so they just point it out. This guy is actually writing very, very good stuff. He's saying that it's a hot mess. The language is a hot mess. You cannot. The STD is very lacking, and you have to. These are real Rust programs before right now. What they find is that the language is a joke. The language is very bad. Just very, very bad. It's just he's officially done with Rust. I think that happens with a lot of pre-Rust programmers. They go back to C++ because the community is very toxic, right? You cannot use unsafe to chase your performance. right? You cannot even you use unsafe, they will just mock you on this Reddit and on this stuff, right? I think what we can do if you're a Rust program, you can just, like I said, using unsafe in all entire part of your code, just to fuck these people, okay? Just to fuck them, okay? Yeah, to just make them suffer. I think this is a good stuff. And this is another it blows my mind, you know. Rust folks claiming using C or C++ violates human rights, you know. Okay, so here's a guy. He's saying that okay, this is a guy who write modern C++ does not save us. Modern C++ won't save us. Okay, we're bad, right? Why do we need to get saved? The logic is very problematic, right? He's arguing that the bad usage of C++ will lead to modern C++ still leads to memory safety issues. That's fine. That's great. But something I don't agree is that the span does not boot method. I think add method is a mistake. But what does he write here? Okay, I think it's in here. He said, he's saying that C++ violates human rights, right? It's bad for society, bad for your reputation, bad for your customer. Using C++ is bad for society? Then Linux, you are arguing Linux kernel, these compilers, they are bad for society? They might be bad for their reputation, but they are bad for society as a whole. I think even the worst C programs is probably going to be more safe than the human, right? Human makes much more mistakes than our C program is doing. The reason you're using this programming language is that programming language is more likely to be correct and efficient than the human. If in these cases it's opposite, we won't use it, right? But he's saying that using C or C++ it violates human rights. It is basically ridiculous, right? And based on his logic, you know, these are real-world CVEs, right? These are real-world memory safety CVEs. So based on his logic, is Rust also a violator of human rights, right? So Rust is definitely also a human right abuser based on their logic, right? So no, using language does not make you violate human rights, right? That's ridiculous. This is completely ridiculous. So, what about people say, oh, Rust in Linux kernel? Okay, I think first these big companies like Google pushes this. Despite the Rust, Google has a long history despising the entire culture, right? The GNU Linux culture. Android, for example, they rely on all on libc. And Linus Torvalds no longer writes a lot of code. I think there's a actual post saying he's not writing a lot of code. And but he actually provides criticism of it. He said, again, excuse my lack of internal Rust knowledge. Which means he's not using Rust. Just some people want to use Rust. Particularly these large companies, they want to use Rust. That does not mean the programmers themselves run Rust. I think what happens right now is that Linus is now no longer writing code. He retires. You know, he basically retires and I can crack for writing code, for example. And he said he's no longer a programmer. He's no longer a programmer, and he just don't care about his own project anymore. He used to have, but he probably lacks. I think this is probably the fundamental reason why he allows the Rust to be allowed in the kernel. Is because he himself is lacking of internal Rust knowledge. He will understand it's a horrible mess when he tries to do that. Probably we're going to see that in the future. Probably going to adapt to Rust either, but we're going to see. And I think the reason basically, and even so, he still points out the problems is Rust. He basically just, he only tries to be more polite. But we know this fundamentally broken. The Rust thing is fundamentally broken. The Rust is fundamentally broke, not acceptable. Because I think Rust panic is very problematic stuff. I would argue like things like all the memory should crash, but I think the Rust panic is a very bad mechanism due to the double free issues. And I don't know how the Linux kernel is going to deal with panic. Probably just going to crash. You don't even have a stack on one in here. probably not linked to libgcc because they're using different torches. So it's very problematic. And these large companies, they're just trying to push it. And I think these companies they don't care about technology itself. What they only care about is money, right? They only care about how to earn money. Probably using Rust will give them money. I don't know because I don't have their internal data. Or probably it's because of the security team inside these big companies. They want to earn money. They just try to propose something to prove their own usefulness so they can earn their wage, right? All their team will disband if they don't propose something interesting. But I think what we're gonna see is that now we will have more Rust style of CVEs. Now we have C has already reduced a bunch of CVEs compared to C, and we are going to see more CVEs in Rust because of they're recreating on Rails, for example. We're gonna see. And WASM, okay. So WASM. Okay, whatever. So Rust people told us that Rust is very good for writing WASM, right? I think it's very problematic of Rust you writing these WASM assembly too, because first you have the binary bloat issue, right? Using Rust to write program is extremely bloat. You can this very strict environment. You cannot just pushing bloating executable right through WASM, right? Because different users might have different network connections. They might not don't have stable connection. If your binary size is large enough, it's probably not working, right? Your website is probably not going to work on many machines, many memory restriction or network restricting machine. You have to control the binary row. But the Rust blows very badly. And this WASM time is bugged, it's deeply bugged. And for example, write VC scores is very bad. I actually, what I actually do is fix around the bring death of Rust WASM. Just to fix around the horrible WASM time. Because it's horrible, they just design very, very bad. I have to write in that code just to deal with WebAssembly, WASM bug time. Or they're saying that we cannot implement on Windows, but how does the FastIO, my library did? I can. You can implement that. You can use that with logs, with file logs, for example. But in general, the Rust folks in general, there's this lack of basic knowledge of POSIX about these basic APIs, and it's just making this horrible, horrible mess here. You can see, I even make an API called WASM barcode write normal. Okay, just deal with the Rust nonsense beneath it. It's just very problematic. And finally, I want to provide proofs here. This is another video. Why would a Python program learn Rust when there's no job? There are no job with it. Kid. Python is probably is now the second most popular language in the world. Probably going to be the top one in near future, probably months later. If the number one language cannot find jobs, how could the learning Rust can find it? How could learning Rust can find a job here? Why would they learn Rust for finding jobs? It doesn't make any sense. Even learning Go, learning C or C++, whatever, even learning Java will give you other jobs. Why would learning Rust give you jobs? And this is a very terrible logic, right? Basically, they're saying that other languages are all crap. Only Rust is the best, which is ridiculous. So, of course, the final we're going to talk about is the Project Verona. Okay, Project Verona, despite Microsoft said it's not designed to replace Rust. If it is become the same, of course, Microsoft will shit on Rust and use the Project Verona instead. Don't say they don't, right? They won't. It's in experimental phase because they don't want to be, right? They want to hide their own purpose. But remember the Java versus C# situation. Yeah, if it's going to happen. Okay, it's going to happen. Right? Don't say it won't happen. It will happen. Okay. So it will happen. I can guarantee it will happen, and it will be other languages try to replace Rust too, because they are saying, oh, you have these much more CVEs with Rust. We're going to design something which is even better. We don't have the double free on panic, for example. We don't have these craze, whatever, this nonsense. We don't have this terrible compilation speed. I think there are some times like the language is doing, but we're gonna see. Rust is definitely not the end of the story, right? It's not just the end of everything. Okay, it's not like that Rust say Rust is going to be the best language in history. Okay, I think we even Java was to claim they are very safe, but in fact Java is plagued with be very safe, right? But in fact Java is plagued with CVEs too. Same with Rust. These people are too naive, basically. I would argue they are too naive. They don't read papers, they don't read these CVE numbers, they don't work real world data like I did, right? It just show you real world data. I fail to see anyone talking about these memory safety issues in Rust, how they come from. So we have CVEs, they don't care. They just live their own echo chambers, and just, I think their logics are very problematic. And if you try to defeat them, I think what happens right now is that no one is using Rust. The happening is that no one is using Rust. It's a problem. No one is seriously using it. Okay. Right? They have some good ideas, they have some good advertisements, and people say, oh, this is great, right? But no one is actually using it. Right? They don't see the problems, they don't see actually what's going on here. And anyone who try to just, oh, this language is terrible. A lot of people like me, or probably you're going to love it, but for me, a lot of people who really understand what's going on here, we understand compiler optimizations, we understand every instructions, we understand how compiler generates code. We know it's not as good as what the Rust folks is claiming here. This video is pretty long, probably. It's probably about rants about Rust, because the major problem is that I fail to see anyone on the internet just talking about these issues with it. Talking about the issues with Rust, these serious design flaws with Rust. And I hope this video will be very helpful for you to think about it. And you should ignore people who think, oh, Rust is going to replace everything. Rust is going to replace not just C and C++, other languages too. And we always talk about C and C++, right? But C and C++ are two different languages, right? If you look at CVE numbers, C++ is actually not the second worst language in the world, right? It's probably Python and Java is more likely to have bugs than C++, for example. But Rust people will say, oh, just C++ destroys everything. Modern C++ won't save us. C++ how bad C++ is, so they can promote their own trash. So that's dishonest, right? What are you gonna do with it? I think what you can do is do what you're gonna do. You should not listen to these people who are claiming those things. It's just very problematic and bad. Okay. Great. And don't say I don't listen to these videos we watch these videos like Rust whatever. Okay. Rust programming language, Rust Microsoft. This video I will watch all these videos. These are all horrible videos, right? They claim they are experts. They just want to earn money, These experts are very bad. I don't know how they become the expert here. Oh, let's talk about the Rust at Microsoft. This is my favorite stuff. Let's just doing a personal. Let's see what personal attack here. Okay. This Brian Lovick. Okay. Don't say I don't watch the video. Actually watch all the videos. They are horrible. That guy claimed he trained people C and C++. Okay? That guy claimed he trained people C and C++. But okay, but you can see even all his code. Okay, he don't write Rust code properly. What he didn't do is basically clone other people's project. Okay, it's basically clone other people. He knows real very serious project. What he always do is just fork other people's project. He himself don't write much of the serious Rust code. Okay, just another fork project. And he also claimed he trained people C and C++ like Microsoft. You know, I can barely find any C project. I remember it's only one C project. And there's no C++ project at all. You cannot find any C++ project. He does not even fork any of C++ project, right? There's no C++ project at all, but he claiming he's training people C++ and Microsoft, whatever nonsense. So it's very dishonest. These people are very dishonest, right? These people, I think they're just at a final point. These Rust advocates are dishonest in general. They don't write code, you know. Do not write code. Neither Rust nor training people C++. Oh yeah, I think you shouldn't say neither Rust. I think neither seriously use Rust. Okay, basically, they basically don't understand how things are going on. Okay. I think if I'm Microsoft, I would fire these people. These people need to be fired. This is just damning our reputation. So that's it. That's all about the video, and hope you enjoyed. Thank you for watching the video. Let me see how to stop it. All day. Oh, how to close the video here? Okay.